Welcome and hello. This is a video tutorial covering HEC ResSim, and in this lesson I'm going to talk about the diversion editor. What I have up on the screen here is a watershed setup. This is a schematic with computation points, a few diversions, and a reservoir. So I threw that into an existing configuration as the name of my configuration, came over to the reservoir network, imported it as network 1, and also sketched out some reaches. So what we have here is our model to discuss the diversion editor. The diversion editor can be accessed by clicking Edit and then Diversions. That brings up our diversion editor dialog box. You can also access this dialog box by clicking on the pointer tool or the diversion tool and then doing a right click on the diversion and edit diversion properties. Let's right click on this first diversion, which takes water from junction CP2 to junction CP6. I labeled it diversion 1. All right, and what we see here in the diversion editor are the name, the description, and then 4 tabs: diversion, routing, losses, and observed data. So if the diversion tab has different methods. First, there's the constant diversion. So if you know the flow rate in CFS, or if you're using metric, it'd be CMS. You can just type that in and you're done. Some of the other diversion methods include the monthly. So for monthly, just type in the flow rate for each month. So if I do that really quick, this is an example showing diversions during the summer months and spring months and no diversions in the other parts of the year. A little graph over here on the right gives you an idea of what it looks like. All right, the next diversion method is seasonal. Now, seasonal is kind of like monthly, except you don't have to define the flow rate per month. It can be a little bit more flexible. So let me type in something else here. All right, so what you're seeing on the screen here is a seasonal schedule for the diversion flow rate. The next one is function of flow. The function of flow method basically defines the flow rate through the diversion based on the flow. And you can specify the source location as well. The default source location will be the upstream junction of the diversion. So let me just type in a few numbers here. What this table of data shows that there will be no flow, no diversion up to 50 CFS at that computation point 8. Excuse me, should be 2. All right. Once the flow rate gets up to 100, the diversion is 50 CFS and then remains 50, regardless of the flow rate being above 100. And then there's a linear interpolation between a flow rate of 50 and 100 CFS, where that diversion is linear between 0 and 50. Next one is the function of pool elevation. So the flow rate through the diversion can be a function of the the pool elevation in a reservoir. So we select the reservoir. There's only one reservoir in this network, and then you can enter data in here to get a diversion versus elevation graph over here. This may be important, for instance, if you want the elevation of a reservoir to remain below a certain elevation, then you can control the water surface elevation that way using the diversion. All right. Next up is time series. Time series is controlled over in the alternative editor, so there's nothing to do here. But if we were to create a alternative, there would be a line item for us to enter a time series for the diversion. Okay, the last one is the flexible diversion rule, and what we see here is basically a Swiss Army knife of diversion tools. It's sort of a catch-all, and it can do all sorts of things. I would recommend just using any of the other diversion methods, but all the diversion methods can be modeled within the flexible diversion rule. However, it's almost overkill. So if you can't, for some reason, define the flow rate through the diversion using any of the other methods, then you can use flexible diversion rule, and it could probably give you the diversion that you want. There's a lots of details with regard to the interpolation, hours of the day, days of the week. A little bit too detailed for this video. There's also a routing tab, losses tab, and observed data tab. Real quick, we're on diversion 1, but diversion um, 3 is unconnected. So if we look at the map here, diversion 1 goes from this river or stream to this stream. Diversion 2 goes back, and then diversion 3 just leaves this second stream. It goes nowhere. So if I open up the diversion editor, you notice that for diversion 3, the routing and the losses tabs are disabled. But that's not true for diversion 2 and for diversion 1. All right, so that's how that works. The routing tab exists again for the connected diversions, and there's null routing, coefficient routing, Muskingum routing. The routing methods in the diversion editor are the exact same as the reach editor. So go back and check out the previous tutorial video, which was number 15, reach editor, and that will give you more details about the how the routing works. In that video, I discussed in detail, or a little bit of detail about how null routing works. It's just there's basically no loss, no attenuation. Coefficient routing, it's based on how much inflow enters the diversion in that time series, in that time period, as well as previous time periods. And then I also talk about the Muskingum method. Also, the user's manual for HEC ResSim also talks about these diversion methods in some detail, as well as all the other methods on this list as well. Losses in diversions are the same as losses in reaches. So if you watch the previous video on reach editor, I talk more about that there. The only difference is there's now a option for return ratio. So return ratio in losses basically is the decimal of the percent of water that actually reaches the downstream junction in the diversion. So you could think of it as the 1 minus the percent losses, but it's in a decimal form. So 1 is the default value. 1 means all the water is transferred through the diversion. There's no losses. If I put like a 0.8, then that would mean 80% of the water makes it to the downstream junction. If I say 0.4, that means 40% of the water makes it to the downstream junction. So based on the flow rate, the model will calculate the losses there. The constant seepage is in CFS, or for metric CMS, and you can just type in a value there if you want to go with constant. And then the third option is seepage as a function of flow, in which case you would just type in your table of values so that the seepage would be based on the flow rate through that diversion. Observed data is a way for you to click the checkbox, hit apply, OK, and then define the diversion amount in a time series when you set up an alternative in the alternative editor. And that's also beyond the scope of this video. So for today and for this video, we just talked about the different diversions and then some of their properties and then how to edit them as well.